Welcome back to another episode of The Encounter, where we talk to senior leaders from the tech industry to get their unique perspectives and insights. Today, we have a very special guest joining us. Please welcome Liz Rice, a renowned specialist in container security. Liz, it's great to have you on the show.
Thanks for having me. It's a pleasure.
So before we jump into all things security discussion, let me give a brief background about Liz. With over 2 decades of experience in the industry, Liz Rice is widely recognized as an authority in open source. She is currently the Chief Open Source Officer at Isovalent, a cloud-native networking company. She's also an AWS hero, a Google developer expert for Go, and she's on the governing board of the CNCF, also on board of OpenUK. She's also an author of 2 best-selling books, Learning eBPF and Container Security. Both of these are published by O'Reilly, and personally, I have learned a lot from both these books. So Liz, welcome again, and let me get started with this fundamental question. How did you become so interested in security, particularly in container technology? How did it all start?
Yeah, so my background is software engineering. I remember when I first heard about containers, or more specifically Docker. I was co-founder of a startup at the time, and we were in an accelerator. And the CTO from the startup next door said, have you heard about this Docker thing? I think it's game changing. Okay, I'll go and check that out. And it seemed really interesting. And I got very interested in the kind of how it works and how things like container images. I remember sort of reverse engineering how container images were put together. At that time, I was doing quite a lot of talks to kind of promote the startup. I went on to work on another startup, and I was talking quite a lot about this kind of container technology that I was finding really interesting, and ended up working with Aqua Security, who are a security specialist. And at that point, I didn't know that much about security, but I knew a lot about how containers work. And I found that knowledge really useful to sort of understand what the possible attack vectors are. And I learned a ton in my time at Aqua about, what different aspects of security are, how those relate to containers specifically. And I find the best way to know that I understand something is to explain it to somebody else. So, I'd be doing talks and then eventually writing the book to really express everything that I'd learned over that time, over those sort of few years that I spent at Aqua. Yeah.
Awesome. So, I am personally a big fan of Trivi and KubeBench. Both of these are open source tools, and I'm sure you had a larger role to play in getting them out and open sourcing them. So, Aqua has a lot of fans and also a lot of customers who use their commercial products. So, switching gears, Liz, you're the co-chair for the Cloud Native Security Con. Now, this is something new. Most of us are familiar with the Cloud Native Con and KubeCon. So tell us about the Cloud Native Security Con and what are the objectives?
Yeah, so security has become such an important part of the discussion at KubeCon, Cloud Native Con, and things like supply chain security, all of these different runtime security tools, some of the really cool things that we can do with eBPF, which is sort of something I'm really spending a lot of time on these days. And with this, increased conversation about security and cloud native, it felt like a good time. I think the CNCF put together this idea of having a standalone conference that would speak specifically to security. And this was really building on the work that was done by Tag Security, so the technical advisory group on security within the CNCF. They'd already been doing Cloud Native Security Day, Cloud Native Security Con, co-located events at KubeCon. And so really the CNCF took that and kind of turned it into a standalone event, which we had in Seattle at the beginning of this year. And it was great because it was rather than being the vast, huge scale that KubeCon and Cloud Native Con are, it was still a pretty sizable event, but a little bit easier to run into the people that you want to talk to about cloud native security. So yeah, it was really, really successful and really nice feel to the event.
So when is the next security cloud native security con happening, and what's
I
the
don't
tentative
actually know.
timeline?
You'd have to ask the CNCF about that. I'm not sure whether that's been announced.
Got it. So Liz, you're also on the board of OpenUK. Now, what does it mean? And tell us more about OpenUK.
Yeah, OpenUK is an organisation here in the UK promoting the use of open technology, that's open source software, but also open data and open hardware, and looking at ways that open technologies can be used more widely, whether that's in government, making sure that the sort of regulatory environment encourages the use of open source, and also encouraging collaboration internationally, fostering the idea of things like entrepreneurship in the open source space. There's lots of talent here in the UK, and there's actually a surprisingly large number of people who are working in open source here. So we're really, with OpenUK, hoping to leverage that talent and kind of foster that use of open for the benefit of everyone, really.
So is this driven by government?
It's not. No, we do work pretty closely with some government departments who've been really supportive of some of the work that we do. And actually, we've had some OpenUK events in the Houses of Parliament. So you might think that we're not strictly, we're not kind of a government set up organisation, but we certainly have the support of a lot of departments and politicians who are really keen to see what open tech can do for the economy.
Perfect. So Liz, this is actually a very tricky question. But when you look at the secure software supply chain, right? I mean, it all starts from developers importing the libraries and goes all the way to running it in production and patching and performing day to operations. So there are various stages of this software supply chain. Now, according to you, what is the most sensitive and most crucial part of the supply chain that needs to be secured? I know you can say everything, but if you have to pick one.
It's such a hard question. I mean, it's kind of whatever you're being attacked through, I guess. I mean, I suppose there's the data that you need to protect, and there are some, fundamental hygiene things that people have to do if they're protecting personal data. And then, so maybe that's kind of the critical thing, if you've inadvertently left a database open to, it doesn't matter what you do with the rest of your supply chain, the data is accessible. Then we've seen a huge amount of emphasis over the last couple of years in looking at supply chain security because of the way, we've seen some pretty high profile cases like SolarWinds, where the supply chain, that kind of build and test process has been compromised. So that's been a huge area of focus, making sure that we know the provenance of every part of our software supply chain. And that can be broken down into lots of different individual pieces. But then there's also the aspect of runtime security, where at one level we deal with this every day. We expect to have network firewalling in place, which is something that happens at runtime. We protect against malicious network packets live in runtime. It's something that's happening there and then. I think increasingly in the future, we're going to see more emphasis on runtime security for other aspects of runtime. So not just the network policies, but also things like what executables are running, or whether executables are running with the permissions that they're expected to run, which files are being opened, that kind of thing. And I think things like eBPF are enabling this kind of technology, because we can build tools that's really powerful, that can sit in the kernel and observe things like what files are being accessed and what executables are running. And use that information we've had that kind of tooling available through things like SE Linux, but eBPF allows us to be much more build much more custom tooling around it and ultimately make it easier to use. That is the thing that it's essential. Security tools won't get used at all if they're hard to use.
I know that was a tricky question, but you actually led that to eBPF, which is my next question. So, I've been a developer and a Kubernetes operator, a DevOps engineer for a long time. And the first time I saw eBPF, it's been so overwhelming because, the word kernel programming in itself is intimidating. And it's very hard to think of, meddling with the kernel and dealing with something at such a low level. So it's eBPF, which is always overwhelming for the Kubernetes developers and operators. So how do you basically explain this in the simple terms? As one of the strongest advocates and the champions of eBPF, how do you put that in the simple terms and make the Kubernetes community more comfortable about dealing with it?
Yeah, so I think before I'd even talk about what eBPF is doing, I'd point out that when we're running in a containerized environment, all of our containers or all of our Kubernetes pods that are running containers, if they're on a given node, on a given machine or virtual machine, all of those containers share a single kernel. And the kernel is the bit that interfaces to hardware. So if you want to do anything that involves, let's say, writing to a file, which involves a disk, or communicating over a network, which involves a wire, writing something to the screen, all of these things are going to involve the kernel because the kernel does those operations on behalf of our user space applications. And the kernel is also coordinating all of our different applications that are running on the same machine. And it's taking care of things like permissions. Is this particular executable allowed to open that file? That kind of thing. The kernel's involved in all of those things. So that makes the kernel this very powerful place to instrument, to add security tooling, to add observability tooling. It's looking after the network. So, being able to change the way the kernel behaves allows us to kind of affect all these different things. Now, changing the way the kernel behaves used to be a case of either building your own kernel or writing a kernel module. And like you say, those are pretty intimidating things to do. And rebooting the machine with a new kernel is traditionally not something you want to do much in a live environment. But eBPF allows us to dynamically customize the way the kernel behaves. It allows us to load programs in dynamically. We don't have to reboot the machine, and we can affect the way the kernel is behaving. So it still is kernel programming, but it can be much sort of smaller and lightweight programs. And it's perhaps, well, to my mind, it's a little bit easier to start experimenting with. I don't think very many Kubernetes engineers will need to write eBPF programs, but they might find it interesting so they can understand, get a mental model, the same way that, most people do not need to write their own container runtime. And yet when I did a talk about writing essentially Docker in 80 lines of code, everybody loved that because it explains how things work. And I think that kind of just getting a feel for how things work gives you this really great position to understand how you use the tools that build on that technology.
Perfect. So for me, the icebreaker was your Python code snippet that you have written in your book, Learning eBPF. So the whole concept of splitting the code between the kernel and the user space and using Python as the language to load that module at runtime, it actually opened up a lot of opportunities and doors to me. In the sense, that's when I understood the power of eBPF. Where you can use a high-level language like Python, but still deal with very low-level plugins, that run at the kernel level. So for all those who are watching this interview, I strongly recommend you to read the book written by Liz on learning eBPF. It actually clarifies lot of apprehensions, concerns, and doubts we have around eBPF. So, Liz, on that note, why do you think eBPF is going to play an important role in the cloud native landscape, and particularly for the cloud native engineers?
Yeah, I think it really comes down to that ability to customize the kernel. In the olden days, pre-eBPF, if you wanted to change the kernel and have it deployed into customer environments, you basically have to get the whole kernel community to agree that that change is, a good idea and is useful to everyone. Whereas with eBPF, we can build much more customized programs that we can distribute to those who want to use them. We're not enforcing them into everybody's kernel. So we can have very bespoke tooling. And I think that's the real beauty of the tooling that's being built using eBPF. It can be very customized. It can be very specific to a particular environment. And it can be very powerful. It's also running in the kernel, so it can be very high performance. So we're seeing lots of observability tools. There's been some really great work over the years. I'll particularly highlight Brendan Gregg, who did a lot of work talking about using eBPF for performance measurement and tracing. And there are loads of tools that he's written and talked about and written books about that give you this ability to measure what's happening pretty much anywhere in your system. And I feel like that's the sort of the building block for, if you can find these command line tools that use eBPF to tell you, okay, tell me every time somebody opens a file, or tell me how much CPU is being used by these particular processes, or tell me how many bytes are being written to files on that machine. This kind of ability to measure things from command line tools, it's pretty natural to go from that to maybe more graphical observability tools. We have some really nice tools in Silium. There's an observability component called Hubble. It lets you see individual network packets, but it also lets you build up a picture of how the services are communicating over a network, or it lets you export information to Grafana, well, Prometheus metrics to Grafana. So you can get these really nice graphs that are built based on metrics that have been collected by eBPF. So they're very lightweight. They're not impacting the performance of the system significantly, but you can get all this really powerful and detailed information that tells you specifically the answers to the questions that you want to ask about your system. And that might be different from everybody else's deployments, and eBPF is giving us this kind of customizable power.
Right. So based on my understanding, Liz, there are two significant domains that eBPF is going to influence. The first one is, of course, observability, and the second one is service mesh. We'll come to service mesh in a bit, but what is the fundamental change or the impact that eBPF does to observability landscape? Are we going to move away from agent-driven monitoring? And you mentioned tracing. Today, people use OpenUK and a lot of distributed tracing tools. Do you see all of them getting magically replaced by one tool written using eBPF?
I don't think it's necessarily just one tool. And I think that's one of the interesting things about the eBPF landscape. We're seeing a lot of different tools giving you these different answers to different questions. So yeah, we're at the beginning of the sort of journey of seeing how eBPF will be used and the kind of range of different tools that people are going to build, and also build successful businesses on as well. There's going to be a lot of really great, there's some really great startups out there doing really interesting things with eBPF. So it's a really great ecosystem.
So does eBPF really take care of those 4 pillars of observability, the melt, the metrics, events, logs, and traces? Can I extract all of them by just running an eBPF program?
I would say it can give you the building blocks to enable all those things. Because it's operating at the kernel level, it's potentially lower level than some of those features. But say, for example, metrics, if those are metrics related to something that's happening at the kernel level, let's say network packet rates or memory usage or file IO, all of those things, the kernel is the best place to gather those metrics. So eBPF is great for that. If we're talking about observing network packets or tracing network packets, again, those packets are in the kernel. They're traversing the network stack in the kernel. So that's a great place to observe them. And whether you want to observe them at different levels in the stack, whether it's, at the socket layer or right at the network interface, you can use eBPF to hook into all these different layers. Whether you want to generate application logs using eBPF, maybe not so much, because your application is in user space already. So you don't benefit much from kind of going to the kernel and back out again. That said, you're writing to a file, you are using the kernel. But so it depends what you're measuring, whether eBPF is the right, it's not the right hammer for every single nail, but it's a very, very useful hammer.
Perfect. Now, coming to the second area, that is getting disrupted by eBPF, which is service mesh. So typically the service mesh is always based on a sidecar pattern where we attach an envoy proxy to every pod and then use that to talk to a control plane. So with eBPF, are the sidecars completely, are they going away? How does this influence service mesh?
Yeah, so there are different service mesh projects, and some of them are taking a variety of different approaches. So there are certainly some service mesh implementers out there who will tell you the sidecar isn't going away. I personally think that there's a lot to be gained by avoiding sidecars. We know from when we first introduced Silium service mesh as a beta, and the reaction from a lot of users was, well, this is great because I can save on the resource usage of my sidecars. I don't have to worry about injecting sidecars. I don't have to worry about the complexity of when you inject a sidecar, you've got multiple containers that might come up in different orders. And depending on what order they come up in, that can create problems. If you don't have sidecars, that's a set of problems you don't have to worry about. So there were a lot of reasons why people were interested in avoiding sidecars just because of avoiding the complexity of it. But it's also giving us this really more efficient network path. So if we step back and think about why people had sidecars in the first place, you have these application pods in Kubernetes that are deliberately, by design, isolated from each other. This is the point of containers. It's the point of pods that, application A and application B can coexist on the same machine without worrying about each other. And to do that, they're given their own networking namespace, their networking stack, effectively. And that's by design. But they're still running on the same machine and running using the same kernel. And network packets that are destined for an application pod have to go through the networking stack on the host machine and then through the networking stack in the pod. And that can be quite, it's an extra level of processing for every single network packet. If you can shortcut that path, then so much the better. Your network latency will improve. If we think about sidecars, that makes things even worse because we've got this extra container in the pod, in the pod's network namespace. So our application has to go through the pod's networking, or a packet from the application has to traverse the pod's network namespace, back up through the pod's network stack to the sidecar, back out again from the sidecar to the host, and then through the host network stack. It's quite a convoluted path. If what you're
But
trying to do
I
doesn't
want to,
involve a proxy, you can have a much
Liz,
shorter
sorry,
network path.
I want to interject there. I want to bring this up. So you made a very interesting point, this whole round trip. But that also brings us some advantages like mutual TLS that is auto magically inserted between pods, and suddenly microservices become more secure because they're using mTLS. So how do you see that in the context of eBPF?
Yeah. So one of the things we need to distinguish is what needs to happen at layer 7, the application layer, which is what the proxy is handling, and what's happening at the lower levels. Now, we still need a proxy to handle layer 7 termination whenever we need to terminate layer 7. So we still need a proxy somewhere. We just don't necessarily need a proxy for every single pod. Again, this is something that different service mesh implementations are taking different approaches to. For Silium, our kind of default is to have one proxy per node, but there are reasons why you might want to have multiple proxies. Maybe you want to have a proxy for a particular application that's particularly noisy, for example. That works, but basically pulling them out of the pod and putting them directly onto the host. Now, mTLS, there's two parts of mTLS. It's giving us mutual authentication, so we understand that the two ends of the connection, we know the identities of those, the two ends of the connection, and they trust each other. And it's also giving you encryption. So having established the identity, we can then use the certificates to encrypt the traffic between the two. Now, it's really one of those situations where it's always worth asking what people really want. For some environments, what they really want is encrypted traffic. And they don't always need the application-to-application identity verification. So one of the things that we can do in Silium is encrypt traffic in the kernel using WireGuard or IPsec. So that way, we know that all traffic is going to be encrypted when it moves from one machine to another. And it's not full mTLS because we haven't done that identity verification, but it is giving us the encryption. And for a lot of regulated environments, that's really what they need. That said, in other environments, the identity verification, the authentication step is important. And we've been working on a kind of next generation authentication approach in Silium, where we'll use the same TLS handshake to establish the identities, but use the kernel level encryption to encrypt the traffic. So we're separating the act of authentication from the encryption. And that's something that there are prototypes available already, but it should be available sort of towards the end of the year in the Silium project. And that will really be, I think, the final piece of the various different requirements that people have when they talk about service mesh.
Awesome. So this is going to reduce a lot of overhead involved in dynamically configuring mTLS, because the whole certificate management and performing this at runtime, that is going to be again offloaded to the CNI network, so you don't have to do it at the application level or layer 7 level. So that is very fascinating. And you have been mentioning about Cilium multiple times, and all roads lead to Cilium and eBPF. So let me ask you this. When I started looking at Kubernetes CNI, my experience was with Flannel. That was the easiest to understand, and I think it got started by CoreOS, and then KubeNet came into picture. And then when I started to implement network policies, it was Project Calico. And then I found Cilium as one of the modern CNIs. So tell us about the differentiating factor of Cilium, particularly when compared to other CNI implementations like Project Calico.
Yeah, so in many ways they have a lot of similarities. the main difference between Silium and Calico is that Silium was built from eBPF right from the get-go. So Calico started with an IP tables-based implementation and then sort of moved to eBPF kind of more recently. There's probably some features that are available in one and not available in the other, and I would definitely recommend people to go and check out exactly what features they want. Silium is now part of the CNCF, so it is a community resource. It's owned by a neutral foundation rather than by one specific vendor, which I think gives a lot of organizations confidence, and it's in the same foundation as Kubernetes, which seems like a very natural home for it. And I think the adoption probably speaks for itself. I mean, we've certainly seen an extension in the use of Silium, particularly since maybe the last 2 or 3 years, since pretty much every Linux distribution now supports eBPF, and that means pretty much everyone can now run Silium, and that caused a huge uptick in adoption. So yeah, I mean, I think Silium, really developed hand in hand with eBPF. It was something that I hadn't really realized before I joined Isovalent, the extent to which the folks working on Silium, there's a good number of folks who are also working on eBPF in the kernel. So the networking capabilities that we have in eBPF have in large part been driven by feature ideas for Silium. If we want to do a certain thing in Silium, we're going to need this kind of support in the underlying eBPF platform. And it's Isovalent engineers essentially who have done that work to add that to the kernel and then build the Silium features on top. So I think that sort of speaks very much to the kind of the talent and the eBPF knowledge that I have the privilege to work with. It's really great.
Awesome. So Liz, is it fair to say that eBPF is acting as the enabler to converge CNI, observability, and service mesh, because it is technically impacting all these 3 domains that have been completely independent and different tracks of the cloud native ecosystem?
Yeah, I think that would be a very, very fair statement. And the more that things like observability and service mesh can be offered by the networking fabric, if you like, that makes life simpler for the user, and it feels like the natural home. Not today, not tomorrow, but at some point in the future, a lot of this stuff will run in the kernel. I don't know how many years ago, 10, 20 years ago, TCP didn't run in the kernel. Now it's kind of a given that that's where it lives. So I'm sure we'll see more and more of these functions living in the kernel, and they can do that through eBPF.
Perfect. So Liz, from the market landscape perspective, is this consolidated, as in, there are very few CNI choices available for customers today. There is Project Calico, there is Project Silium, and there are commercial implementations by Tigera, Isovalent, and so on. And then VMware has NSXT. So is this all that can happen in the CNI market landscape? Do we have room for other things to come up, some new innovations? And what do you see in this?
Yeah, there are a few other CNI implementations that, there's a couple of others in the sandbox in the CNCF. So I wouldn't say that, innovation has stopped. That said, I have seen a couple of really nice comments in the last few days where people have been basically saying, today Silium is the kind of obvious choice, which, I fully support that. I think Silium is a really great implementation, and the fact that it's an open source project and that the community can contribute to it, I think really gives it a very solid footing for the future.
Excellent. So we are almost coming to the end of this interview, and there is one question that I ask almost every leader in the cloud native ecosystem. So how do you see generative AI impacting the cloud native security and the cloud native the evolution?
Yeah, it's the question on everybody's lips at the moment, isn't it? Yeah, I think it's going to affect all sorts of different levels and in all sorts of different timeframes. At one level, we're already seeing people using tools like CodePilot and the other assistive code writing tools. That may improve productivity. It may also help introduce some more bugs and some more security issues. If we can hallucinate bad facts, I'm sure we can also hallucinate some very bad code. But there's no question in my mind that people are using those tools today. Are they using them to find security vulnerabilities? I expect so. Are they using them to fix security vulnerabilities? Probably, yeah.
Yeah.
And you can build from there to more longer term concerns about will we in 10 years time even think about writing code as a human rather than maybe we'll just do it for amusement purposes rather than and leave the real legwork to the AIs. I don't know. The future is going to be very interesting.
But in the near term, I would love to see a chatbot sitting in the Kubernetes dashboard, which is hopefully deployed securely, where I can say, implement network ingress and egress with these ports. And, it basically goes ahead and patches my running pod by applying the network policies and basically reconfigures my deployment to make sure it is completely protected and secured. So I think that is the use case that we are looking forward to, where you can chat with a Kube bot that sits right inside your cluster and takes your instructions and does some configuration changes.
Yeah, I've not actually tried asking, ChatGPT generate me some network policy YAML, but maybe it's worth having a go.
Yeah, but we got to make sure, we thoroughly validate it before we apply. So,
Sure, yeah.
As I said, the current LLMs are hallucinating, and it all depends on how well they're trained on these logs and the Kubernetes YAML files and so on. We are not there yet. But interestingly, we are heading towards that direction, where the LLMs are learning a lot about DevOps logs and DevOps processes and Terraform files. And so it's not very far where we can really chat with the bot to implement network security policies.
Yeah. I think I can certainly imagine that. If an AI can write an email for me, then I think it can probably have a stab at writing a network policy for me.
Absolutely, I think that is the point where generative AI will meet DevOps and SREs. Great. So, Liz, that brings us to the end of this interview. Thanks so much for the insights. I personally learned a lot just interacting with you, and I'm sure this interview would be found very useful by the community, by my viewers. So, thanks for joining, and we'll do a follow-up, maybe a deep dive on CNI, Isovalent, and Silium. So, I'm going to have you back in my show very soon.
That's great. Thanks for having me, Johnny. And it's been a pleasure.
Thank you.